Have you ever looked back at historical events and felt like things were just repeating themselves? We humans are totally wired to see patterns everywhere, even when they aren't actually there. I mean, we can find a face in a piece of burnt toast, so we can definitely find cycles in the grand narrative of human civilization. But how do we know if these historical cycles are actually real, or if they're just the product of our pattern-seeking brains? Well, welcome to this explainer. Today, we're going to translate the abstract, almost magical geometry of history into rigorous mathematics by breaking down a formal methodology from the Coherence Dynamics Laboratory. It's designed to do one very specific thing: separate compelling historical fiction from mathematically verifiable facts. Okay, here is our roadmap for today's explainer. We're going to start with the geometry of history, then we'll examine the 1936 candidate pivot as a case study, explore binary octave folds, unpack discovery versus confirmation, and finally, we'll walk right through the Independence Gate. So let's jump right into Section 1, the geometry of history, and specifically the illusion of structure. This really gets to our central conflict. Are we just seeing what we want to see? It's a fundamental human flaw to view history as this grand, predictable clockwork full of symmetrical reflections. But the research hits us with a pretty harsh truth here. Structure has to be earned. Just looking back at history and finding things that seem to align, what researchers call retrospective correspondence, that doesn't mean you've discovered a law of nature. We need a rigorous methodology so we aren't just drawing targets around bullet holes, We have to know that a proposed pivot of history isn't just a total coincidence wrapped up in a good story. That brings us to Section 2, the 1936 candidate pivot. This is our exploratory case study. Let's ground this abstract theory by looking at a very specific, motivating example. The year 1936 has actually been hypothesized as a central axis of historical symmetry, but simply pointing to a date doesn't prove it holds any geometric weight. We have to look at the raw data. And when we examine the day-by-day historical timelines of early 1936, the sheer density is staggering. In just a few days, we have a major attempted military coup in Japan, the opening of the first Volkswagen plant in Germany, and major battles on the Ethiopian front. Every single year is just packed to the brim with major geopolitical and social shifts. And that relentless density just keeps going. Fast forward to June of that exact same year. You've got Haile Selassie making an impassioned speech to the League of Nations as his country is invaded, while over in the US, Gone with the Wind is published. Because historical records are so unimaginably vast, if you pick literally any year as a pivot, you will inevitably find dramatic events mirroring it. And that is exactly why we need an unforgiving mathematical filter. Which leads us perfectly into Section 3, binary octave temporal folds, where we talk about building the lattice. To test these patterns properly, we absolutely need a rigid measuring stick. We can't just pick intervals that happen to conveniently land on interesting wars or treaties. We have to commit to a mathematical rule before we ever even open the history books. So you create a geometric grid by mapping intervals of 2, 4, 8, 16, and so on. You start by declaring your pivot year, let's call that P. Then you step outward in both directions using powers of 2. Plus or minus 2 years, then 4 years, then 8, 16, 32, all the way up to a strict limit K. You must declare this maximum limit in advance, so you can't just keep extending the octave until you finally find a data point you like. So here is the formula that formalizes this whole procedure. It completely removes human bias from the selection of the dates. I know it looks a bit complex, but it's actually wonderfully simple. L is the lattice, a set of precise coordinates on the timeline. If our pivot is the year 2000 and our limit K is 5, our lattice automatically generates the years 1999, 2001, 1998, 2002, and so on, all the way out to 1968 and 2032. The math decides where to look. We don't. Now for Section 4, discovery versus confirmation. This right here is the core methodological conflict. Generating a lattice is really only step 1. We must rigidly separate discovering a pattern from actually proving it. Most historical pattern matching completely fails right here. People use the exact same historical data to form their hypothesis as they do to prove their hypothesis. In statistical science, that's a fatal error. The core rule here is that derivation is not validation. Discovery is just noticing a pattern or deriving a candidate pivot. That's perfectly fine, but confirmation demands something entirely different. You have to test your pivot against a completely separate, independently coded dataset. You literally cannot use the events that gave you the idea to prove the idea is true. To maintain total objectivity, researchers must declare a discovery exposure register to document exactly what historical evidence they've already seen. If you've already peeked at the historical events in a 64-year interval while dreaming up your theory, you have to log it. It doesn't mean you've done something nefarious, but that specific interval is now contaminated by discovery. It can no longer be used as unseen evidence to confirm your claim. And that brings us to Section 5, the independence gate, which covers our null testing protocols. This is the gauntlet every single hypothesis must run to become objective reality. The independence gate protects the analysis from the investigator's own bias. The cardinal rule is, earlier interpretive confidence is never later evidential entitlement. In plain English, if you built your theory by reading Wikipedia timelines, you cannot validate it using those same timelines. Furthermore, you have to pre-register exactly how you will measure a hit or a miss before you ever touch the fresh data. So, how do we measure this? We use a specific matrix to measure whether historical events occupy our calculated coordinates more frequently than sheer random chance. You calculate two scores: the event score, which is what fraction of historical events land on your coordinates, and the lattice score, which is what fraction of your coordinates actually have an event on them. You need a high result to even suggest a broad correspondence. But even that isn't enough on its own. A claim absolutely must survive these specific null models. N1 tests your lattice against a completely random spread of dates. N2 tested against other possible pivot years you consider but threw out. And N3 tested against intervals that aren't binary, like counting by 3s or 5s. Look, if your supposedly magical pivot year doesn't score statistically better than a completely random baseline, then you don't have a structural lattice. You just have a coincidence. Applying this exact machinery back to our 1936 case study yields a very specific diagnostic classification. Let's decode it real quick. P1 means they explored multiple candidate years before settling on 1936. I1 means some intervals were peaked at during discovery. K2 means they decided when to stop the octaves based on what looked interesting. And CX means the historical archive used was contaminated by prior exposure. Therefore, the ultimate objective verdict on the 1936 axes is that it remains an exploratory and testable hypothesis, but it is strictly not independently confirmed. And honestly, this brilliantly illustrates the power of this framework. It doesn't prove the 1936 theory wrong, but it honestly and rigorously categorizes it as unconfirmed. The methodology works exactly because it forces researchers to admit that their compelling historical story has not yet passed the brutal mathematics of the independence gate. I want to leave you with this provocative thought. A symmetrical temporal lattice is a beautiful construction, but true scientific value isn't defined by the compelling stories we tell. It's defined by the rigorous tests those stories survive. We humans are deeply wired to find meaning in the chaos of time. But as this framework proves, an unyielding mathematical null test is literally the only thing standing between a fascinating illusion and the actual architecture of history. Thanks for joining me on this explainer. Keep questioning the patterns you see.